Hi, and welcome to Kotlin Basics. In this section, we'll look at classes and how to define a class with fields and constructors. We'll look at data types like string, int, boolean, and others, as well as mutability and nullability, which are concepts that are enforced much stronger in Kotlin compared to Java. We'll look at flow control statements like if, when, try, catch, as well as functions and how to define parameters with default values and how to define return types. We'll also look at some new Kotlin concepts like string templates, smart casts, and expression body syntax, which all help to reduce boilerplate in your code. It's time to look at basic types and syntax. In this video, we will look at how to define classes and fields, as well as the primary constructor. In a later video, we'll see how the primary constructor can cooperate with any secondary constructors. We'll look at how to define functions and how to override functions. As mentioned earlier, mutability and nullability are concepts that are enforced very strongly in Kotlin, and now we'll get to look at what that actually means. We'll talk about the any class, which is a superclass for any Kotlin class, and how it differs from object. We'll also look at equality and how to compare objects. This is a valid Kotlin class definition. The class keyword followed by the class name is all you need to define a class. Now, this class is final by default, so if you wanted to make it extendable, you would have to add the open keyword in front. Kotlin classes are also public by default, meaning that you don't need to add public class to every class definition. But if you want to make it private, add the private keyword in front. Now let's add a constructor and a couple of fields. So the constructor is added in parentheses after the class name. And the val keyword in front of each parameter will make sure that the parameter actually turns into fields as well. Now, val is a keyword that defines an immutable value. So if we looked at the bytecode for this class, it will contain two private fields, one for name of type string and one for age of type int, as well as a getName and a getAge function. Now, if you wanted to be able to change the values, you would have to turn these into vars instead. So the var keyword means mutable, so the bytecode would also contain a setName and a setAge function. Now let's look a little closer at the constructor. Let's say you wanted to create a class with a private constructor. Then you would actually have to type out the constructor keyword before the parenthesis so that you could annotate it with the private word as well. Now let's say you're using some kind of injection framework and you wanted to be able to inject into the constructor, and it requires you to add this constructor annotation. So you could do that. Let's say we have this simple annotation defined. You could add the @inject before the constructor keyword as well. Alright, that's enough theory. Let's explore this class a little further in IntelliJ. Here is our person class again, this time written inside IntelliJ. I'm using the immutable version of it, where the parameters and fields are specified with the val keyword. Now this might look a bit alien to you coming from Java, so let's look at some alternatives. So if we hover over, let's say, the first field and select Alt-Enter, IntelliJ suggests to move this to the class body. Let's do the same for the age and then discuss what's going on. So now the constructor only contains parameters, no fields, since there is no val or var keyword in front of the parameters. And the fields themselves are declared inside the class, just like in Java. What might look a bit strange is that we don't have any types declared for the fields, and the reason for this is that Kotlin can actually infer the type from the parameter. Of course, it might look better, especially in a class, to actually specify it. So if we hit Alt-Enter, you can select Specify Type explicitly to get help with the class type. And let's do it manually for this age parameter or field. Great. So now this looks a bit closer to what you would do in Java, I guess, but we can take it one step further as well. Every class has an init block which will run as part of the constructor. So let's declare this init block. Inside the init block we have access to the parameters from the constructor, so we can use that to assign to the fields. So this name equals name, and this age equals age. So this name here is the actual field, and the name here is the parameter from the constructor. Now, IntelliJ is not entirely happy yet, and the reason for that is that if you remember, a val is immutable, and we tried to first assign to it here, and then assign to it again in the init block, so we got to choose. So let's remove the assignment up here. And IntelliJ is happy again. Now, this might help you understand what's really going on, but it's a bit verbose. So IntelliJ is actually suggesting with the squiggly line here that you can join this field with the assignment. So hit Alt Enter again. We can select Join Declaration and Assignment Helper. So let's do the same for the H field. And we're back to where we were. Before we move on, let's have a quick look at the generated bytecode. The bytecode is generated by the Kotlin compiler, and that's what is actually running on the JVM. So go to Tools, select Kotlin, and Show Kotlin bytecode. Let's have a look. So the name field is defined by a private final string called name. We also have a getter called getName, which returns a string. So this shows you the encapsulation that you get by default in Kotlin. A private field is generated and then a getter. Here we have the private final int age and the getter. Let's see what happens if we change the name to a var. We still have the private field, we still have the getter, but now we also have a setter. So this is important to keep in mind when working with Kotlin, that under the covers, this is turned into an idiomatic Java class with getters and setters and private fields. In fact, let's step even further back and turn this class back into an idiomatic Kotlin class. So let's remove these fields declared inside the class and move them back to the constructor. Hit Alt Enter on the field and select Move to Constructor. Do that for both fields. And let's remove the curly braces because we don't have any code inside and we don't really need the empty class body. So let's hit Alt Enter and remove empty class body. Now we're in a file called person.kt and we have defined a person class. Now that doesn't prevent us from defining even more classes or even more package level functions inside the same class. So this is a good place to create a main function. So you can either write it out or write PSVM and hit Tab. Now let's instantiate this person and assign it to a value. We need to pass it parameters, so a name and an age. Great. So let's try to reassign to the age of this person now. And you may notice that we're not using getters and setters. We're just using the property name. And under the covers, the getters and setters are going to be used because, as we know from the bytecode that we looked at earlier, the fields are actually private, but there are exposed getters and setters. Right now, actually, we don't have any setters, we just have getters, and that's why this code doesn't compile. So if we wanted to assign to the age property of the person class, we need to make it a variable so that we get a setter. So let's hit Alt Enter and make variable mutable. So all it does is change the val to a var, and we now have a setter, so this code compiles. Now let's look at what happens if we try to assign null to it. Compiler is not happy again because int is not a nullable type. Types just declared with the type name is not nullable in Kotlin. To make them, we have to add the question mark after the type name. And now this code compiles again. Of course, if property can be null, we have to deal with it somehow. So let's see what happens if we try to find out the next age for this person. So let's create a value called next age and say that it's person.age plus 1. Now this doesn't work, and the reason is that age is nullable, so we could get a null pointer exception at runtime, and Kotlin won't allow that. So to deal with it, you could either check it before you assign, or Kotlin also has a shoot yourself in the foot function called double bang. So what you're telling the compiler now is that, yeah, I think this value is not going to be null, so please let me do this. And you should probably never do it. A better way is to assign some kind of default value for this. So we could say that if age is null, then we'll treat it as 0. And you can use the Elvis operator for that. So say question mark colon and then 0. So this means take the age if it's available, or use 0 and then add 1. You also might have noticed that I didn't declare any types here. So it's perfectly valid to do so. So we can add int here, and we can add person here if you want to. And whether you do that or not kind of depends on the complexity of the class, I would say. So also on personal preference, of course, but if others are to read your code and it's not clear because of maybe you assign a value using a function call, then you probably should declare the type. Now let's look at functions. Let's go back into this person class and add back the curlies so we get a class body. And we could actually create a function called nextAge, which uses this code and return an integer which is one higher than the age assigned to the person. So let's declare a function with the fun keyword, call it nextAge, and it doesn't take any parameters, so just empty parentheses, but it returns an int, so you add a colon and then the return type. Then the curlies for the function body, and then return and just age. Since we're already inside the person, we have access to the age. Great. So that's a simple function that returns an int. We could run this now, so let's remove this code and, for example, print person next age. Let's try that. Now, what if we wanted to add parameters? So we could add a function that says is older than and some other person, which returns a boolean, for example. So let's add the fun is older than, and then it's called the person other type person, and it's going to return a boolean, but I'm going to show you a trick here. So let's say return, and we still need to use this trick since it's nullable, so maybe we get rid of that for now. We say it's not nullable anymore, and now IntelliJ says that you can see that this code is a bit grayed out, and it says that it's not needed anymore, so let's remove the useless Elvis operator. Now it's easier for us to write this function as well. So let's say is older than would be other age is smaller than age. And now Kotlin tells us that there is a type mismatch. The inferred type is Boolean, but unit was expected. So the default return type of a function is unit, or void if you want, but we want it to be a Boolean. And unit, you don't need to specify. So if you don't return anything, you don't need to write unit. That's why we didn't do that in the main function either. So let's now get some help to change the return type of this function. It adds in Boolean for us. So to try this, we could add person2, for example, and then write person is older than person2. And let's say that this one is only 2 years old. So we're older. That's great. Now let's look at overriding functions. So if you hit Control O, then you get a list of functions you can override in this class. And you also see something other funny here. And that is that the superclass or our class is not object like we're used to. It's Kotlin.any. We'll look at that more in a second. So let's select the toString function, for example. Now what you see here is that Kotlin added the override keyword for us. It's not an annotation like in Java, but it's an actual keyword. And whenever you override a function, you have to add this keyword. If you don't add it, but you shadow a class or another function from the superclass, then Kotlin is complaining and saying that you're hiding a member of the supertype. And our supertype is any, which declares the toString function. So it needs the override modifier. It can help us to add it back with @enter and add override modifier. Okay, so what we can do here is to return, for example, a helpful string telling us the name and age of this person. So let's use a string template. Inside double quotes, we can actually access the variables. We don't need to use a string format like we do in Java. So we can just write $, and then name is, and then $age years old, for example. Okay, so if we get rid of this again, and now we just print the person, well, actually just the person. We don't need to call toString, of course, because that will be done for us. We get the toString function overridden inside our person object. So what about equality? Let's get rid of this output window and override the equals method. So Control O, select equals to get the function already set up for us. And let's return that for an object to be equal, then other should be a person, and we can use the is instead of instance of to say that other is person, and other name should equal our name. Now, in Kotlin, you would use just the double equals instead of the equals function call as you do in Kotlin. It means the same thing as the equals function in Kotlin. So now that we have the equals function, we could use it, and let's create another person here, and let's call this one 1 and this one 2, and let's change the name so they're not the same, and then say person 1 equals person 2. Now, if you write equals like this, it's actually valid, but Kotlin is going to tell you that that's not the way to go. So let's replace it with the equals equals operator instead. Now let's run this code. We should get false. That's good. Now let's change so they have the same name, and now equals should return true. Great. So let's talk about any versus object. Any is the superclass of any Kotlin type, but any is not exactly object. However, at runtime, any will turn into object, but there are some differences. At compile time, for example, any does not contain wait, notify, and notify all. Also, if you look at the equals method that we overrode, the type there is any, a nullable any, and not an object. So this is something to look out for, but normally you would just use any where you normally use object. And there are also some other corner cases where you need to think about this concerning generics, so we'll look more closely in that in an upcoming video.